Hello, and welcome back to Shiksha DaCosta. Today, we're going to learn how to convert a quadratic from standard to vertex form by a process called completing the square. And that's our goal for the day. If we are given a quadratic in the standard form, can we convert that to vertex form and go backwards as well? It's really actually quite easy to go from vertex form to standard forms. For example, if we're given h of x equals this equation right here, can we turn that into standard form? Yeah, we just follow the order of operations and expand and simplify. So first we will deal with the brackets. We can't actually subtract these, so we'll go to the exponents next. So this squared means x minus 1 times itself. And to expand this, we just use FOIL. So x times x is x squared, x times negative 1 is negative 1x, negative 1 times x is negative 1x as well, and negative 1 times negative 1 is positive 1. And we just add those together. And that is the expansion of just this portion. The rest of the equation we have to leave as is. So negative 2.25 multiplied by all of this, and then plus 9. Now over here, I can simplify this a little bit by combining these two like terms into just negative 2x. And now I can expand these brackets by multiplying the coefficient that's in front by all three of these terms. And now finally combining these two like terms at the end into positive 6.75. So this is that equation in standard form. And to convert an equation, a quadratic, from vertex to standard form is absurdly easy. All we have to do is expand and simplify. Converting it back to vertex form, though, is much more difficult. It's a process called completing the square. And the first step is to look at just the first two terms here and factor out the a value. The a value is always the number that's in front, or the coefficient of x squared. So I'm going to divide both of these two terms by negative 2.25. Negative 2.25x squared divided by negative 2.25 is, of course, just x squared. And 4.5 divided by negative 2.25 is negative 2. We're going to leave the plus 6.75 outside for now. Our second step is to take the coefficient of the second term that's inside the bracket. So take negative 2, divide it by 2, always divided by 2, and then square our answer. And then whatever the resulting answer is, we're going to take this and add and subtract it inside the brackets. So by adding and subtracting it, we basically added 0, which means we have left it, we have not changed the equation at all. And now notice that we've got something very similar to this step over here. We've got negative 2.25 in front. We have x squared plus minus 2x plus 1 over here, which we know would actually factor into x minus 1 squared. This is why we call this completing the square, because we're trying to create a perfect square trinomial. The problem is we can't factor it unless we deal with this negative 1 somehow. And the way we get rid of this, or remove it from the brackets, we know we have negative 2.25 of these. We have to multiply these at some point, so we might as well multiply it now to get it out of the brackets. So we multiplied it by negative 2.25 to get positive 2.25 at the end there. Now, this actually is a perfect square trinomial. Like I said, this is why we call this completing the square. And while we are actually factoring this into x minus 1 squared, we can also combine our like terms on the outside here. So if I add these two together, I get 9. And when I factor this, it will always be half the number over here. So this is negative 2. So it'll actually be x minus 1. And notice this is exactly the same as the original equation that we had. And that's how you complete the square. That's how you go from between vertex and standard form. A quadratic relation in vertex form can be rewritten into its standard form just by expanding and combining like terms. But if we want to go backwards, we have to do a much more complicated process called completing the square. The reason we would want to complete the square in the first place, of course, is vertex form gives us a bunch of really useful information that standard form might not. For example, it gives us the maximum or minimum value of the quadratic. That's just the exact same as the k value. It also tells us what value of the independent variable will actually maximize or minimize. So what value of the independent variable gives us this number? It's always going to be h. Keep in mind here that this is x minus h. So for example, in this case, the minimum, let's see, this quadratic, the a value is positive, so it opens up. So -1 is the minimum value, and that happens when x equals -3, the opposite sign of this. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.